It was the very first object that visited our vicinity in the solar system from outside the solar system. It moved too fast to be bound to the sun.
The James Webb Space Telescope has just captured a discovery that has set the entire scientific world into an almost breathless state of disbelief. Nestled within the R2 Swan region, a gaseous nebula located against the black canvas of space, an anomaly has emerged. Unlike the luminous dust and shimmering gas that typically fill such stellar nurseries, this anomaly displays unmistakable motion, rhythm, and what many are now daring to call the signature of life. The sheer audacity of that conclusion has electrified astronomers, physicists, and biologists alike, for the Webb was never expected to find anything so unambiguously alive, and certainly not something moving toward our own system. Before we start, please don't forget to like and subscribe to our channel for more updates. The images first appeared as irregular blotches within the otherwise symmetrical patterns of glowing gas and dust. Astronomers initially suspected they were simply data artifacts or distortions caused by interference. Yet as the Webb's instruments recalibrated and returned to the same region again and again, the pattern not only persisted but revealed progression. The anomaly shifted between frames, altering its position in ways that no drifting cloud could explain. What once seemed static began to show coordination, measured, consistent, purposeful. For the first time in modern astronomy, a telescope had not just witnessed a celestial object, but something alive within the depths of a nebula. The R2 Swan region itself has long been admired for its striking beauty, resembling a cosmic bird with wings spread in flight. It is a stellar nursery, a place where stars are born from collapsing clouds of gas. But no one predicted that such an environment could harbor life, let alone something that appears to thrive and move deliberately within the turbulence of its interstellar cradle. Unlike planets with protective atmospheres and liquid oceans, nebulae are thought to be harsh, radiation-filled expanses where complex molecules struggle to survive. And yet, Webb has shown that nature continues to outstrip the boundaries of human imagination. Spectrographic readings taken alongside the visual data sent waves of unease and wonder through the scientific community. The anomaly reflected not the typical chemical signatures of dust or rock, but complex organic structures, chains of carbon-based molecules assembled in ways never seen in raw cosmic material. These patterns bore the fingerprints of self-organization, hinting at metabolism, at systems interacting with energy to sustain form. As the Webb focused its instruments further, faint pulsing emissions were detected, timed almost like a heartbeat. This was not random interference. It was a pulse, steady and deliberate. Then came the revelation that turned speculation into astonishment. Over the span of weeks, the Webb tracked the anomaly as it subtly adjusted its trajectory. It was no longer stationary within the Swan, but slowly, deliberately moving outward, toward our own galactic neighborhood, not drifting like space debris, not pushed by solar winds, but following a course, motion with intent. The realization reverberated across observatories worldwide. Something alive in the nebula was coming closer. The implications are staggering. For decades, humanity has gazed into the heavens wondering if life existed elsewhere. Now, the question has abruptly shifted from if to what, and the what carries with it both fascination and unease. Life in a nebula suggests an organism capable of surviving extreme radiation, vacuum, and temperatures near absolute zero. That alone defies biology as we understand it. On Earth, life requires water, nutrients, protection from radiation. But in R2 Swan, the rules are rewritten. Here, something thrives in the very conditions that sterilize most known matter. Such resilience implies biology of unimaginable sophistication, or perhaps even something that straddles the line between biology and machinery. Astrobiologists examining the data propose the possibility that this is not life as we know it, but a hybrid phenomenon. It could be a living structure composed partly of organic molecules, partly of mineral or metallic components, something akin to a cosmic-scale symbiosis between matter and energy. The pulsations recorded might not just be heartbeats in the biological sense, but energy exchanges, signals, or methods of communication. The complexity of its spectral emissions suggests a system that not only survives but adapts, interprets, and reacts to its environment. The most unnerving factor remains its trajectory. The Webb's calculations, corroborated by terrestrial observatories, reveal that this entity is not moving randomly. Its vector aligns directly with our solar system. This path could be coincidental, a natural drift coinciding with our location, but the precision of the movement suggests otherwise. It suggests intention. Even if intention is too human a word, the sheer improbability of such direct movement rattles the frameworks of astronomy and biology alike. It is as if the cosmos itself has answered back to centuries of human longing and speculation. Philosophers are already grappling with the existential ramifications. If life can exist in the flaming crucibles of nebulae, then the universe is teeming with forms that defy human categories. The Copernican principle, which insists humanity is not central or special, is underscored yet again. But this discovery goes further. It suggests we are not merely accompanied by microbial life on distant planets, but by beings vast, possibly sentient, possibly ancient, whose very biology is written in the chaos of stars. To witness such life is to be humbled at the enormity of existence. For scientists, however, the focus remains tightly fixed on deciphering the phenomenon. What energy source drives its motion? How does it sustain its structure against the battering forces of a nebula? Can it manipulate radiation itself, using the starlight and cosmic rays around it as nourishment or propulsion? Each new data stream from the Webb peels back one mystery only to reveal another, deeper and stranger. Some models suggest the entity spans hundreds of kilometers, perhaps even more, making it not an organism in the terrestrial sense, but something colossal, a living constellation of matter. Others argue that its scale is deceptive, that what appears vast might in fact be a collective, a swarm, countless smaller entities moving together as one. The concept of a swarm is particularly compelling. If these are individual life forms, they may function in unison, like flocks of birds or schools of fish, guided by emergent intelligence rather than centralized control. In that case, the pulsations recorded by Webb could be signals of coordination, resonant exchanges binding the swarm together into a larger organismal network. Life, in this sense, would not be a single creature but a collective intelligence stretching across kilometers of nebular space. Such a life form could alter human understanding of consciousness itself, reframing intelligence as something communal rather than individual. The moving entity challenges not just biology and philosophy but physics itself. Propulsion without engines or chemical reactions raises baffling questions. Is it using magnetic fields? Is it bending the flows of plasma within the nebula to glide forward? Or is there some form of biophotonic drive at work, capturing and redirecting light itself to generate thrust? These possibilities ignite fierce debate, for they hint at a command of physical laws so elegant and efficient that even advanced human technology pales beside it. Whatever it is, it travels in silence, carving its path through interstellar space without the roar of rockets or the glow of exhaust. Cultural reactions to the discovery are as varied as they are passionate. Some see it as a divine affirmation, a celestial being birthed in light and flame. Others treat it as the first true encounter with extraterrestrial neighbors, beings whose biology is written not on planets but in the heart of stars. Writers, artists, and dreamers find their imaginations inflamed, crafting stories and visions of encounters yet to come. For skeptics, though, caution remains essential. To leap too quickly to conclusions is to risk error, and so the mantra persists. Collect data, verify, test, repeat. Still, the emotional charge of the discovery is undeniable. Humanity has long wondered if something out there might be watching. Now perhaps something has begun to move closer. Astronomers remind the public that the entity remains unimaginably distant, measured not in miles but in light years. Its approach is slow, vast distances absorbing decades into their scale. Yet even so, its direction cannot be ignored. For the first time in history, humanity watches as not a comet or asteroid, but something alive makes its way in our direction. The Webb's mission, once thought to be a journey into the silent past of the universe, has unexpectedly become a bridge to a startling present. What unsettles some observers most is the question of origin. Was this life form always present, dwelling unseen in the Swan until the Webb's eye finally captured it? Or has it only recently emerged, born from processes yet undiscovered, a new being in a cosmic cradle? If it is ancient, its endurance is beyond comprehension. If it is new, then humanity has witnessed the genesis of something extraordinary. Both possibilities carry profound weight. In either case, it means that the processes of life are not limited to the fragile balance of Earth, but are woven into the very mechanisms of the universe itself. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on the James Webb finding something alive in R2 Swan? We want to hear from you. Thank you for watching and see you next time.